Semester 1 test review covering modules 1 through 5. Question 1. State the domain and range of the function in set builder and interval notation. Now set builder notation, so if I did the domain, so for this one, the domain would be all x values. That means I could put any x in here and it will land on the blue line. So in set builder notation, this would be x such as x is all real, or you could say is an element of real. Now in interval notation means it would be, since it's all real, it would be parentheses negative infinity to positive infinity. Now with infinities, you use the parentheses because the infinities aren't a specific number, so therefore it can't equal infinity or negative infinity, so we use the parentheses. The range, talking about all the y values. Now there is a low point. It never goes below this point, which is -2. So we would say the range in set builder notation would be y such that y is greater than or equal to a -2. And in interval notation, since it can equal -2 on the low end, we would use a bracket and it would have -2, and it goes to positive infinity, which we would use parentheses. Question 2, determine if the following functions are one-to-one. So let's just name this one as f of x and this one as g of x. Now for the functions to be one-to-one, for it to be a function, first it has to pass the vertical line test. So this one, f of x, passes the vertical line test, and it has to pass the horizontal line test, which it does. So f of x is one-to-one. Now if we look at the other one, we have California to the population of millions. If we're looking at the population in millions, it is a function because each state only has one population. And if we go the other direction, they are also one-to-one. But if we were to follow the numbers that they have for the number of representatives, California would have 53 representatives, Texas 36, New York and Florida both have 27. So they go one way, so it's a vertical, it passes the vertical line test, but the horizontal it doesn't, because if I were to switch, say these are my x's and these are my y's, if I were to flip it the other way, the number of representatives, 27, has two different x values. So that cannot work. You can't have the same number of representatives for two different states. So no, this one would not be one-to-one. Question 3. Determine whether each function is linear or nonlinear. So again, linear is like y equals mx plus b, or y equals a number. So here, g of x is like y equals a number. So this one would be linear. F of x equaling 2x squared minus 7. Since this has an exponent, I know that this is a quadratic, and quadratics are nonlinear. And h of x equaling the square root of 3x plus 3/4. Now this is actually in slope-intercept form because my slope is a square root of 3 and I have a y-intercept. So this one would be linear. Now if Semester 1 test review covering modules 1 through 5. Question 1. State the domain and range of the function in set builder and interval notation. So for here, the domain can be any x value I can put in there because it keeps going to the right and to the left. So the domain in set builder notation would be x such as x is an element of real, or you could just say x is all real. And in interval notation would be negative infinity to positive infinity. And you'll notice I'm using parentheses because since infinities are not a specific number, it can't equal infinity. So therefore we use parentheses. Now the range is talking about our y value. So our y value in set Builder notation, you'll notice that it never goes below -2. So in set Builder notation, it would be y such as y is going to be greater than or equal to a -2. And then we would have it in interval notation. It can equal -2, so I use a bracket or like a closed bracket, and it goes to positive infinity with a parentheses. Question 2. Determine if the following functions are one-to-one. So here I'm just going to label this as f of x and this one as g of x. So for it to be one-to-one, one x value has to have one y value, and one y value has to have exactly one x value. Now if you were given a graph, it has to pass the horizontal line test for it to be a one-to-one function. Since f of x does pass the horizontal line test, we would say this one is one-to-one. But if I go to the table here, each population of millions has exactly one number of representatives. But if you look here, for Florida and New York, the number of representatives are the same. So if I were to reverse the order, 27 would match up with two different populations. Therefore, this is not one-to-one. Question 3. Determine whether each function is linear or nonlinear. So if it's linear, it could be written in y equals mx plus b format. Nonlinear means they would have some exponents involved, or there's an x in the denominator of a fraction. So this first one, g of x equaling 7, would be linear because this would be a horizontal line. So we would call this one linear. Y f of x equals 2x squared minus 7. That one would be nonlinear because it has an exponent. So this is quadratic. So nonlinear. And the next one here, since I have the square root of 3 and I have 3/4, this would be linear because the square root of 3 would be my slope and the 3/4 would be my y-intercept. So this one would be considered linear. Question 4. Solve this absolute value equation. Now the first thing I want to do is get the absolute value by itself. So I'm going to add 9 to both sides. And this is going to give me 2 times the absolute value of 5x plus 1 has to equal 4x plus 26. Now to get my absolute value completely by itself, I'm going to divide everything by 2. And now I have the absolute value of 5x plus 1 is equal to 2x plus 13. Now with absolute value is the distance from 0. That means I can go to the right of 0, which is positive, and to the left of 0, which is negative. So I need case 1, which would be 5x plus 1 equals the positive form of 2x plus 13. And then I'm going to use the negative form, so I have 5x plus 1 is equal to the negative form, which would be a negative 2x minus 13. And the negative form, all you're doing is just multiplying that right side by a negative 1. Now I can get all the x's to one side, so I'm going to subtract 2x, and then I'm going to subtract 1 on both sides, and we're left with 3x is equal to 12. Divide by 3. X is going to equal positive 4. And on this side, I'm going to add 2x to both sides. And I'm going to subtract 1. And this is going to give us 7x equaling a negative 14. Divide everything by 7. X can also be a negative 2. So these would be my two solutions for X. Question 5. For his graduation party, Santino's parents have hired a catering company to provide the food. The company charges a setup fee of $150. They also charge $6 per person for the first 50 people and $4.50 per person for each additional person. Write a piecewise function that models the amount the catering company will charge if P people attend. What would the cost for 85 people be? So the first thing we're going to do is create our piecewise function. So I know it's going to be f of p, and this is going to equal, and then in here I know it's going to be $6 per person plus the startup fee of $150. If p is less than or equal to 50, but it has to be greater than, or we'll just say greater than 0. Now anything after 50, it's going to be $4.50. So I have to take that in consideration. So for 50 people, that's 6 times 50, that's 300, plus the $150 startup fee is 450. So we know it's going to be 450 plus then $4.50 per person afterwards if P is going to be greater than 50. So now that's my piecewise function. Now we want to look at what's the cost for 85 people. So if P is 85, I have to look at my piecewise function. And I know that 85 is bigger than 50, so I'm going to use this function here. So I have $450 plus $4.50 times 85. And that's going to give us a total cost. So f of p, or f of 85, is going to give us, and we'll grab our calculator here. So we have 450 plus 4.5 times 85. That's going to give us $832.50. So $832.50 is what would the cost be for 85 people. Question 6. Solve and graph this absolute value inequality. Again, we want to get the absolute value by itself, so I'm going to add 5. And we have the absolute value of 4x minus 8 is less than 16. Now, since this is a less than symbol, I know it's an and, or I can write the abbreviated form, which I would have 4x minus 8 is less than 16, and it has to be greater than, and I know I wrote this the less than symbol, but I'm reading it from the variable side, so greater than a negative 16. Now you could write it as two separate ones and use the keyword and. I'm just writing it as a simplified form. So now I'm going to add 8 to the inside and the outsides. And that gives us 4x is less than 24. And it's greater than negative 8. To get x by itself, I'm going to divide by 4 on the inside and the outside. And I would have x is less than 6, but greater than a negative 2. So now on a number line, I would have negative 2 here. I would have a 6 here. They're 8 apart, so half of 8 is 4. So the middle number would be 2. So now I have a open circle at negative 2 and an open circle at 6. It has to be greater than negative 2, but less than 6. Next, question 7, we're going to write y equals 2/5 x plus 14 in standard form. Again, standard form has to be in ax plus by equals c format, no fractions, no decimals, a has to be a positive integer. So in order to get rid of the fraction here, I need to multiply this whole side by 5. But whatever I do on one side, I have to do on the other side. So right now I have 5y equals 5 times 2/5 x is 2x plus 5 times 14 is 70. Now my x is already positive. I need to keep it positive, so I don't want this 70 here, so I'm going to subtract 70. And now I have negative 70 plus 5y equals 2x. I need my x and y on the same side, so I'm going to subtract 5y on both sides. And now my answer would be 2x minus 5y equals a negative 70. Question 8. Find the 13th term of the sequence. Now the formula for this one would be a subscript n equals a subscript 1, the first term, plus n minus 1 times the common difference. Now you can use this formula when you are given the first term, which we have a subscript 1 here, and the common difference is always what are you counting by. So if I take the second term of 47 minus the first term of 56, I will get the common difference of negative 9. So this is our D. So now if I substitute the numbers in, I'm trying to find the 13th term. So to find the 13th term, I'm going to have the first term of 56 plus n minus 1, so 13 minus 1 times the common difference of negative 9. Now if I grab my calculator, I'm going to have 56 plus parentheses 13 minus 1 and parentheses times negative 9, and we will get an answer of negative 52. That means the 13th term would be a negative 52. Question 9. State the degree and leading coefficient of each polynomial in one variable. So I look at my terms here. I look at the one that has the biggest exponent, which here is 4. That's my degree. So we would say this has a degree of 4, or you can say quartic. And it has a leading coefficient of 6. This next one, I look at my exponents. The biggest one is 5. So you would say the degree, you can say 5, or you could say quintic. And the leading coefficient in front here is a 1. Question 10. Describe the end behavior of and identify the domain and range of each function. So here I have a function negative 5x cubed. Since the degree is odd, I know it's going to be like an S shape. I know the leading coefficient is negative, so that means it goes down from left to right. So it's going to look something like this. So the end behavior would be as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches negative infinity. The domain for odd functions are all real, and the range for odd functions is also all real. This next one, I have an even function. Even functions, the end behavior faces the same direction. Since this is a positive even function, they both open upward. So the end behavior would be as x approaches negative infinity, y approaches positive infinity, and as x approaches positive infinity, y approaches positive infinity, And the domain for an even function is all real. And the range for an even function, since it opens upward, it's y is greater than or equal to 0. Question 11, solve the system of equations. Here you can either use substitution or elimination. I'm going to use elimination because my y's are already opposite. They have opposite signs. So all I need to do is make this y to be a negative 5y. So I just have to do is multiply this by 5, which will give me 15x minus 5y is equal to a negative 55. And this other one, I'm just going to bring it across, which will be 6x plus 5y equals a negative 8. Then I can combine like terms. So this will give me 21x. The y's cancel off, equals a negative 63. To get x by itself, I'm going to divide by 21. And I'm left with x equaling a negative 3. Now to solve for y, I'm going to put negative 3 in for x in one of the two equations. I'm going to do this bottom one. So I have 3 times negative 3 minus y equals a negative 11. So this will be adding 9 to both sides. And I would have negative y equals a negative 2. Divide by negative 1. Y would equal a positive 2. So my solution for this one would be x is negative 3 and y a positive 2. Question 12. It says write a quadratic function with points at 0, negative 2, 0, 8, 0, and 0, 80. So for this one, I'm going to, since they give me my zeros, I'm going to put it in factored form, which factored form would be y equals a times x minus p times x plus q, where p and q are going to be your zeros. So I have this x minus 2. Right now I'm told this, x equals a negative 2. To make this equal to 0, I'm going to add 2 to both sides, and I have x plus 2 equals 0. That's one of my binomials. And the other one here, if x equals 8, I would need to subtract 8 on both sides, and my other binomial would be x minus 8 equals 0. And this part here would be my x and my y that I can plug in here. So if y is 80, I need to find the a when my x is 0, and I'm going to put these binomials in here, so that's plus 2 times 0 minus 8, and I can solve for a. So 2 times negative 8 is negative 16a equals 80. To get a by itself, I'm going to divide by negative 16. And a will have to equal a negative 5. That means my quadratic function would be y equals a negative 5 times x plus 2 times x minus 8. Now that's just one form I wrote it in just because I was given the factors. Question 13, solve by completing the square. So to complete the square, I'm going to have x squared minus 26x plus blank has to equal a negative 48 plus blank. Now to complete the square, I'm going to take my b, which in this case is a negative 26, divide it by 2, which is negative 13, and then square it, which will give us 169. But whatever I do on one side, I must do on the other side. And we complete the square, so we have a perfect square trinomial here, which in factored form would be x minus 13 squared equals negative 48 plus 169 will give us 121. Now we can use the square root property. So to undo a square, we find the square root, and that gives us x minus 13 equals a positive 13 or positive 11 and a negative 11. And to get x by itself, I'm going to add 13 to both numbers. And we're left with x equaling 24 and a positive 2. Question 14, what are the solutions of 3x squared plus 27 equals 0? So the solutions means the roots or the x-intercepts. So I'm going to subtract 27 on both sides, and we're left with 3x squared equals a negative 27. To get x by itself, I'm going to divide by 3. And I'm left with x squared equals a negative 9. To undo a square, I find the square root. And that gives us x equaling a positive and negative. The square root of 9 is 3. And a negative is I. So it's going to be a positive and negative 3i. Question 15, state between all consecutive integers in which a real zero is located and explain how you know. Well, when the f of x or your y values change signs, we know that they cross the x-axis there. So there's a sign change here, there's a sign change here, and those are the only two places where there's a sign change. So we're going to say between, and this is where we write the x terms of it. So between negative 6 and negative 5, there's a x-intercept, and between negative 4 and negative 3. And my explanation would be, we look for sign changes in our y values. Question 17. Simplify by synthetic division. So really we're dividing this by x minus 2, which in synthetic division, remember we have x minus a. Our a is what we're going to divide by, so our a is going to be a 2. So then we write the coefficients here. So this is a negative 4, positive 5, a negative 2, and a negative 9. We bring the first term down, so which is negative 4. And then we multiply on the diagonal. So 2 times negative 4 is negative 8. Add straight down. Multiply on the diagonal. Add straight down. Multiply on the diagonal. Add straight down. And what we have left is our solution, or our quotient, which is always going to start with the one less degree of our polynomial. So this would be negative 4x squared minus 3x minus 8. So I'm going to write this down. So this would be a negative 4x squared minus 3x minus 8. And our remainder is a negative 25 all over x minus 2. Question 17. Simplify by subtracting. So I'm really subtracting all of this, so I'm just distributing the negative 1. So I'm going to stack this, so this would be a minus 6x cubed minus a negative x squared, which means plus 1x squared, minus 2x. And if I'm subtracting a negative 7, I'm really adding 7. So now combine like terms, I get 2x cubed plus 6x squared plus 8x. Negative 3 plus 7 is a positive 4. Question 18, simplify by multiplying. So I'm just going to FOIL this. So 2y squared times 4y squared is 8y to the 4th. 2y squared times negative y is a negative 2y to the third. And 2y times 1 is a positive 2y. Then distribute the negative 6y. So negative 6y times 4y squared is a negative 24y cubed. Negative 6y times negative y is a positive 6y. This would be a negative 6y squared. And I think I forgot to put the square here, so negative, this would be a positive 2y squared. Then we distribute negative 6y to the 1, which would be a minus 6y. And then our last one, distribute the 3, which will give us a positive 12y squared minus 3y and plus 3. Then I can combine like terms, which will give us 8y to the fourth minus 26y cubed plus 20y squared minus 9y plus 3. Next, here we're dividing, so this is by a monomial, so I'm going to divide everything by 4x squared y. And one thing to remember is when you divide like terms, when the bases are the same, you subtract the exponents. So in here, our answer would be 24 divided by 4 is 7, x to the third, y to the third, plus 12 divided by 4 is 3. This would be x y squared minus 44 divided by 4 is 11. X, the y's divide out, minus 60 divided by 4 is 15. The x squared y divides out, so that would be my solution. Question 20. Find the term in a plus b raised to the 12th where the exponent of a is 5. So I know I'm going to have a term of a to the 5th, and then b, it has to add up to 12, so I know that it's going to be b to the 7th. Now, a quick way is to find the coefficient, and without using Pascal's triangle, I can use the combination function. So this would be 12, choose, and then it's always the second exponent, which would be 7. So on our calculator, if I grab our calculator, I'm going to hit 12, math, go to PRB, and it's number 3, and then we're going to put 7. That's going to give us 792. So the term is going to be 792, a to the 5th, b to the 7th. Question 21. A video game developer determines that the profit in thousands of dollars from a new video game can be modeled by the function p of x equaling negative 2x squared plus 120x minus 1,000. When x is the price of each game, the game will be profitable if p of x is greater than 0. So to make the game profitable, the price should be more than blank and less than blank. So the quickest way of doing this one is grabbing our calculator, going to our y equals, and we're going to type in the function, and we're just going to find the zeros. So negative 2 x squared plus 120 x minus 1,000. And I'm going to change my window settings. So I need to get to at least a negative 1,000 in here. So let's make this, let's say negative, we'll make this a negative 1,000. My y's, let's count these by 500s. My x's, I can't have negative amounts, so I'm going to put this as 0. The maximum, I don't know how much they're going to charge, so I'm going to make that generous. So I'm going to make that 100. And then we're going to count these by tens. Now again, you can choose whatever numbers you want. I just want to be able to see where it crosses the x-axis. So here and here. So if I go to my table by hitting second graph, and I want to find out when when y is 0. So when y is 0, I see a 10. So it's got to be more than 10. And if I go back to my calculator, let's scroll down further. When my y is 0 again, and 50. So when it's less than $50 but more than $10, it will be profitable, which just means it's above the x-axis. So if I go to my graph here, you can see it's above the x-axis. That means these are profits when it's between these two marks. Question 22. Use negative 5x squared plus 10x minus 15 equals 0 to find the discriminant, and then use the discriminant to describe the number and type of roots. So the discriminant formula is b squared minus 4ac. So my b is 10. So if I square the 10, that's 100 minus 4 times our a, which is negative 5, times my c, which is negative 15. And this is going to give us negative 4 times negative 5 is 20. 20 times 15, negative 15 is a negative 300. So I have 100 minus 300. This is going to give us a negative 200. So our discriminant is negative 200. Now, since my discriminant is negative, I can't find the square. That would be like in the quadratic formula, finding the square root. I can't find the square root of a negative number. Therefore, there is no real solutions. So I have no real solutions, but I do have two imaginary solutions. So I would have two complex roots or solutions. Now, if it was a positive number and it's a perfect square, then I would have two real rational roots. If it was a positive number that's not a perfect square, then it would be two real irrational numbers. Now, if I had if it equaled 0, say if the discriminant was 0, then I would have one real rational root. Question 23. Graph this inequality. So for this one, I want to find my axis of symmetry. So I take my b, or the opposite of b, which would be a positive 2, divided by 2 times my a, which is going to give us a positive 1. That means my axis of symmetry is at positive 1. So I'm putting my axis of symmetry. And if I put 1 in here, that'll be 1 squared minus 2 times 1, which is a negative 1, plus 8 is going to give us 7. So my vertex is going to be at 1, 7. So that's my vertex. And my axis, or my y-intercept, is going to be at 8. That means it's one step to the left because a quadratic is symmetrical. So if I put a 2 in here, that's going to also give me an 8. So because this has an equal to symbol, I know this is going to be a solid line. So it's a parabola that opens upward. And now the shading part. It has to be less than the graph. So if it's less than that, that means it's everything underneath would be a solution. Question 25. Use a graphing calculator to solve x to the fourth plus 3x squared minus 5 equals negative 4x cubed by graphing and round to the nearest hundredth. So we're going to use our graphing calculator. We're going to use the graphing feature on here. So we are in our y equals, just clear what we have, and it's going to be x raised to the fourth power plus 3x squared minus 5. That's going to be one function, and the other one's going to be a negative 4 x to the third. And then we're going to graph this, but to go back, I'm going to hit zoom number 6 to go to standard form here. So that's the first function. The other one is right here. So to zoom in a little bit, I'm going to change the window setting. I'm going to keep the x's to, I'm going to do negative 5 to a positive 5. And I'll keep that the same, so then that might be a little bit easier to see where they cross. You can see here, I might have to change the window setting for the y maximum. Let's make that 30. Then it might be a little bit easier to see. Let's see, it's going to cross again, so let's try 50 this time. Hit graph. Here's one. Here's the other one. So now let's go to second, trace. We're going to find the intersection, so number 5. We're going to go to this side over here. So first curve is the parabola. Next one is the other one. And if I hit x a third time, it's going to tell us, and we would just want the x, so the nearest hundredth, so this would be a positive 0.84. So I have x equals a positive 0.84. And then if I go to the other side, so I hit second, trace, we're going to go to intersect, so number 5. And we're going to go to this other side. So we're going to go closer to that one. So I'm just going to use the right arrow button. So over here, hit enter. Second one, hit enter. Enter a third time. It's going to give us a negative 3.22. So x equaling about a negative 3.22. So for this one, we only have 2 real solutions right here. So they only cross in 2 places, but it could be a possibly some more, but those would be they would be imaginary. So we wouldn't actually have any other zeros. So the parts that they cross, they would cross at about these 2 spots. Question 25. The pool in a penguin exhibit has a volume of 1,085 cubic feet. What are the dimensions on the pool? So for this one, we're going to write our quadratic here. So we know the dimensions, so volume would be 2x times 2x plus 3 times 5x minus 2. And this has to equal a volume of 1,085. Now, in order to solve this one, we could use our calculator and we can graph to figure out when what x would be for this one. But let's just make this into a quadratic, or not into a polynomial. So let's FOIL this. So this will give us 4x squared plus 6x, and then let's multiply that by 5x minus 2. So this will give us 20x cubed minus 8x squared. Distribute the 6x, and that will give us a positive 30x squared minus 12x. So we would have a polynomial of 20x cubed plus 22x squared minus 12x. This has to equal 1085. So to solve this one, we're going to take our calculator. We're going to go to our y equals, and we're going to find out where do these two equations like this polynomial and then this line, so treating it like a system of equations, where they meet up. So I'm going to clear what I have here, and so I'm going to have 20x cubed plus 22x squared minus 12x. And then the other one, it's going to be 1085. Now I'm going to change my window setting. I know we're only going to be using positive numbers because we're dealing with dimensions of length. So this will be 0. I don't know what my x maximum is going to be. So I'm going to just make that conservative. I'm going to make that, let's just say, we'll just say 10. And then count by ones. The y minimum, I know it's going to be 0. So we have to have a positive number. The maximum, I need to get at least to 1085. So I'm going to just make that 2500 so I can make sure that I see 1085. And I can count these by, let's count them by 250. And if I hit graph, here's that cubic polynomial, and here's the 1085. I need to find out what's the x-coordinate of the meeting part where they cross. So to find that, I'm going to hit second trace, intersect number 5, hit enter 3 times, and it's going to tell us it meets here when x is 3.5. So now if I go here, if x is 3.5, I can find the dimensions now. So I would have the dimensions of the height would be 2 times 3.5, which will give us 7 feet. And then the width, which would be 2 times 3.5 plus 3, which would be 7 plus 3, which is 10 feet. And then the length would be 5 times, so 5 times 3.5 minus 2. And if I did 3.5 times 5, that's 17.5 minus 2 gives us 15.5 feet. Let me erase that to make that a little bit clearer. So 15.5 feet. Now if I were to multiply all three of those numbers, so 7 times 10 times 15.5, I would get 1085, which is what I have here. So those would be the 3 dimensions of the exhibit, or the pool in the exhibit. Question 26, use factoring by grouping to find the factors of 3x cubed plus 4x squared minus 25x minus 10. So if I were to factor this by grouping, I can factor out an x squared. That leaves us with x plus 4. And over here, I can factor out a negative 25, and that leaves me with x plus 4. That means I have factors of x plus 4 times x squared minus 25. Which these would be a difference of 2 squares. And if I were to solve this I would make each of them equal to 0. And x would actually be a negative 4. And over here, I would add 25 to both sides and find the square roots. X would also be a positive and negative 5. But always the factors, as if I were just factoring that, we would just have here, this would also be x plus 4 times x minus 5 times x plus 5. So these would be in factored form. These would actually be the solutions. Question 27, solve for x. So we're solving this. So in order to do that, we're going to do the same thing we just did over in question 26, but actually solve it. So for here, we didn't actually need to solve it over here. We just need to factor it. Here we're going to go all the way through with it. So factor by grouping. So I can factor out an x cubed. That's going to leave us with 2x minus 5. And over here I can factor out a positive 8. And that's going to give us a 2x minus 5. So that means I have x cubed plus 8 times 2x minus 5. And if I make each of them equal to 0, I would have x cubed plus 8 equals 0. Subtract 8 on both sides. I would have x cubed equals a negative 8. To undo a cube, I find the cubed root of both sides. And because I can find the cubed root of negative 8, x would actually equal a negative 2. And over here, I would have 2x minus 5 equals 0. I would add 5 to both sides. I would have 2x equals 5. Divide it by 2. X would equal 5 halves. So my solutions would be x equaling negative 2, but that would be like multiplicity of 3. So I would actually have 3 roots of negative 2, and then x equaling 5 halves. Question 28. Prove that x cubed minus y cubed is equal to x minus y times x squared plus xy plus y squared. Now, one way of doing this is if I were to distribute here, so multiply them, I would end up with x cubed plus x squared y plus xy squared, and distribute the negative y, which would be a negative x squared y plus xy squared minus y cubed. And all I have left is x cubed minus y cubed on the right side, and on the left side I have x cubed minus y cubed. So both sides are equal to each other. Question 29, use synthetic substitution to evaluate. So with synthetic substitution, they're telling us put 8 in for x. So if I do that, they're going to say, what do I get as a result? So one way of doing that is using synthetic division. So if I put an 8 in here, I have negative 6, a positive 52, a negative 27, and a negative 31. Whatever my remainder is what my solution would be. So if I bring down the bottom number, multiply on the diagonal, add straight down, multiply on the diagonal. So a 32 minus 27 would give us a 5. Multiply on the diagonal, so that's 40. Add straight down and you get 9. So we should get a number of 9. Now to verify this, if I go to my calculator, I can just plug everything in here. So I'd have negative 6 times 8 raised to the third power plus 52 times 8 squared minus 27 times 8 minus 31, we would get 9. So either way, you will still get the same solution. Question 30, state the possible number of positive, negative, and imaginary zeros of the following function. Now, to find the positive, I want to find out how many sign changes there are. So this is Descartes' rule. So I would have one sign change here, one sign change here, and one sign change here. So a sign change here, a sign change here, and a sign change here. So that's 3. And I can go down by 2 because they have to work in partners. So if I go down by 2, I can have 1, and I can't go any further than that. Now the negative forms. Negative forms mean if I put a negative x in here. So if I have a negative x in here, this would be a minus 5 times negative x squared plus 6 times negative x minus 4. So this will give us a negative x cubed. Negative x squared is x squared, so that stays as a minus 5x squared minus 6x minus 4. So you'll notice they're all negatives, so I don't have any sign changes, so I would have 0 negative real roots. Now this exponent tells me the total that I could possibly have. So I can have a total of 3 solutions, or zeros. So if I have 3 positive, I can't have any negative or imaginary. But if I have 1 positive, 0 negative, that means I have to have 2 negative in order to get a total of 3. So those would be the possible numbers of positive, negative, and imaginary zeros. Question 31. List all the possible rational zeros of this polynomial. So now we can use p divided by q, and this is our q and this is our p. We need to write all the factors of p. So that's a positive and negative 1, positive and negative 2, positive and negative 4, positive and negative 8, and a positive and negative 16. And the q, the factors of 4 would be positive and negative 1, positive and negative 2, and positive and negative 4. Now to simplify these, let's do our factors or our fractions first. So I would have 1 divided by 2, which is positive and negative 1/2. 1/4 would be positive and negative 1/4. The other ones I would not have any other fractions involved. So now I can do integers, which would be all the top parts because they would give us positive and negative 1, positive and negative 2, positive and negative 4, positive and negative 8, and positive and negative 16. Because like if I did 8 divided by 2, that gives me my 4. 8 divided by 4 gives me my 2. 16 divided by 2 is the 8. 16 divided by 4 is your 4. So these would be all my possible rational zeros. Question 32. Sketch the graph of a third-degree polynomial function with factors x plus 3 and x minus 1 squared. So now to find the zeros, all I have to do is make each of these equal to 0. So if I did x plus 3 and make it equal to 0, x would be a negative 3, so I know it crosses at negative 3. And then if I did x minus 1 squared equals 0, find the square root of both sides, I would have x minus 1 equals 0. X would have to be a positive 1. But since I have 2 of them, I know it's not going to cross there. It's going to touch and then bounce off of it. Now, if I want to find out the y-intercept, to find the y-intercept, I would have x plus 3 times, and if I were to FOIL x minus 1, this is just x squared minus 2x plus 1. If I FOIL that, that's x cubed minus 2x squared plus x, and then distribute the 3. It'll give us a positive 3x squared, a minus 6x, and a positive 3. I would have x cubed plus x squared minus 5x plus 3. So if x was 0, I would have a y-intercept at a positive 3. Since this is a positive cubic means it goes up from left to right. So that means this is going to go down on the left side. So it goes down. So that means from left to right, it's going up. So it's going to cross at -3. It's going to go up here. And then it's going to come back down. And then it's going to pop back up here. So that would be a just general sketch of this polynomial. Now, if I were to take my calculator and verify it, I can clear what I have in here. Now, let's just say I put these factors in here. So if I did x plus 3 times x minus 1 squared, and then hit graph, there what my function would be. I don't need to know exactly where these would be, where it's turning at this point, because I just want to sketch the graph of it. If I wanted to, I could put some numbers in for what I think x would be and plot some points down. By the way, this would be a general sketch of that function. And questions 33 and 34. What are the factors of x cubed plus 9? If it cannot be factored, then select prime or just write prime. So for this one, this is a sum of cubes, which would mean if I have a sum of cubes, I can use the SOAP method, which means this would be as a plus b, so the same, times our a squared, opposite sign, multiply this would be ab, always positive b squared. So what I'm doing is I'm finding the cubed roots of these first two terms. That becomes our first binomial, and I use the same sign as I have here, and then I square the first term, and then I use the opposite sign, multiply the two cubed roots, gives us a middle term, and then square the last term to get our last one, and that's always positive. So if I find the cube root of both of these, I would now have x plus 2, and then if I squared the x, I get x squared, opposite sign, so minus, 2 times x is 2x, and then square the last term, but it's always positive, so that's going to be 4. So this would be my two factors. I can't factor x squared minus 2x plus 4 any further than that. So those would be my factors. On this one, since they're telling me one of the factors is x minus 5, I can use synthetic division to bring this down. So if I did a 5, this would be a 1, a negative 4, negative 47, 210. Because I want to find out what would the other factors remain after here. So this would be a 1, multiply, add straight down, multiply, add straight down, multiply. So we know that's a 0. So this is going to be an x squared plus x, 1x minus 42. And I can factor this. And I know that x plus 7 times x minus 6 gives 7 times negative 6 is negative 42, and 7 plus a negative 6 is a positive 1. So these would be my other factors of that. So those are the types of questions you can expect on a semester test.